Okay, so we come to our second panel expert roundtable discussion. Warm welcome also from my side, Michael Kompatscher. I have the pleasure to moderate this, and I think it's more about now. We heard a bit what are the expectations, what are the topics, quite wide approaches, different perspectives. Now we are more in the discussion, and where are we now? What is state of the art? Where is research? What do we already know? Where are the technical challenges or answers? So, and I think that's a perfect round. Very short introduction, in the same way as before. Everybody will introduce himself directly. I have Michael Derungs here from the firefighters and firefighter instructor from the department in Zurich. I have Christoph Müller here, CEO of Virturail, with a lot of experience already of vehicles underground. Philipp Strüby, CEO of Motix, also part of the Subspace Energy Hub, and integrator of battery solutions in large heavy vehicles for the construction site. We have Tony McDonald here, battery producer from Ireland, Xerotech, also member of the Subspace Energy Hub. Christoph Ziegler from Normed Equipment and New Technologies, who gives us an insight how they changed their full fleet to electric. So starting with this, I just wanted to give a few slides about what was already done. Somebody or some of you may know this, that we here in the Hagerbach Test Gallery a couple of years ago already did for the Swiss Road Authority some investigations on batteries, special lithium-ion batteries, also NMCs basically, but it was more for car size. It was not for the construction side. It was really to assess a bit the risks in tunneling in general compared to known traditional vehicles. So this was in 2017, 2018. Electric mobility and road tunnel safety, and then risk minimization of electric vehicles in fires and underground traffic infrastructures during 2019 and 20. This was with the Swiss Material Testing Institute, the federal, with CETU from France. Amstein Walter was in the lead. Publication is available for download. We will put this then also on our homepage, because all the discussions also that we do here, we are going to make a white paper out of this and also publish this accordingly, so everything is recorded and also available then for further use. Now, what did we do exactly? We compared actually in an experimental approach. Standard vehicles are known, so we looked at the approach was more to look at the battery itself. We wanted to do this in a very realistic way. We also excluded everything. We went really for the worst case scenario. We did full mechanical damaging. We excluded all battery management systems, so really to have the worst case scenario, we let all the battery, for the full module that we analyzed, 100% thermal runaway through all in different methods. So we were shooting through, we had a knife going through all the cells. At the same time, we damaged it with explosives so very, very worst case, and the batteries were all fully loaded at full load stage. So just to see in this extreme situation what the measurement, what the targets are in terms of contamination, of chemicals, of environment, of impact. Michael was strongly involved from the firefighter side and approached this, so he has a perfect view also on this. Now, we had different scenarios. You see, we just looked at the module, and we were looking how the smoke propagation is going. We were looking at extinguishing water. Also, is the extinguishing water contaminated? We differentiated also, because once the thermal runaway of the lithium-ion battery, you cannot stop it. So it was put under cooling water, And the up-contamination of the cooling water was, of course, different than just the flushing, extinguishing water of the firefighters that you have. So we checked also what this means for our sewage channel system. This was analyzed. We checked the clothes of the firefighters. We were looking about the infrastructure itself, about cleaning possibilities after the test, how far materials, contaminations in a tunnel are transported, what are dilution effects based on ventilation. So a lot of topics. Just to give an overview that this was done. We checked this in a closed environment, so we had a very defined area which was 100% closed, the test site with 250 cubic meters of volume. And we also had the second scenario really in the tunnel, typical road tunnel, open, but not actively forced ventilation. It was just the standard slow air flow that went through with 1.5 meters per second. So this is not a lot of ventilation to show what really comes out. And actually, what we found out, there was a modified thermic risk. Actually, there is a different heat behavior. We measured 2 meters away from the cell, we measured directly beneath the cell, and we measured inside the cell what the temperature development actually is. So you saw from 2 meter distance, basically, it did not even go above the 100 degrees centigrade. But it was also nice to see that all fire protecting measures typically done in tunneling for underground construction, there are different curves. You know, there's the ISO curve for fire protection, there's the RWS curve, so different situations. You see how these are. Basically, the typical ZTV tunnel measuring curve is not so far from what we are used to. Just the temperatures are far above, so on a very high threshold level. And I think that was important to get these results and to see these things. We also saw that between the emissions, there is a clear difference, of course, because the battery has heavy metals in, so of course there are more heavy metals to find based on cobalt, nickel, manganese, lithium and fluorine, compared to a standard vehicle that is understandable. So there's some atypical emissions, but also from the cleaning we saw standard measures for cleaning for pollution. In particular, if there is ventilation, this goes strongly down, and typical cleaning measures work. So you can clean it as you are used also for traditional vehicles. So battery fires with nickel, manganese, cobalt batteries in closed room will lead to partially atypical emissions, increase the toxicological risk because there are some other pollutions, but this can be, with clear measures, very well handled. Make a difference in the extinguishing water and in cooling water, where you have an up contamination, the longer the battery is in, and then you need to waste or take care of this cooling water in a separate way. The high dilution effect that you have with the extinguishing water, you can handle like standard extinguishing water in fire incidents. So pre-treatment of the wastewater shall be considered. And what we also saw in general, so there is fire, vehicle fire remains vehicle fire. I think that is a very important outcome. There is no critical contamination of large ventilated infrastructure that we found. We measured this after 2 years also to see if there is persistent contamination, and checked this. We didn't find this. We still find some small traces, but not of relevant amounts. They do not cause an essential change in accident management, according to our outcome, and they do not lower the value or availability of the facility itself. So we checked also about corrosion risk on the infrastructural equipment and everything that was installed. This a rough summary about the research topic that we did, and as Michael was involved, He has a completely different perspective. He is every day involved in firefighting. So I think it's a pleasure to have you here, and I give the word over to you, that you introduce yourself and share about your experience with battery electric driven vehicles, fires.
Okay, thank you, Michael. First of all, I have not so many words in English, sorry for that, but sometimes it's good to be in this 5 minute slot. We all read about it. Okay, it's interesting for me because at the end it's the question what you expecting from us when you have a fire or what else. Just go in and do it. Or when I see these big projects you do, you have to have a concept anyway before it starts. You have to contact the fire brigade who's coming to you, and you have to do that before. It's a difference. Is it on a project, and a big project like you did, or is it just a fire on the street or where else? And yeah, my goal is to give you some hints. What are our challenges when we have to handle fires, primary fires? And yeah, for me, I don't have to go into details, but this one, I'm also, how did you say that, petrol head? I'm also petrol head, but I'm not against these technologies because I'm a private pilot and I've flown this electric airplane. I'm not against these technologies, but I have to say where our problems are. This is interesting. It's near here in Jenice. I can fly in these beautiful environments in the mountains. We have to handle crashes, for sure. That's one point. Cars or airplanes or whatever. We have to handle this. This is the future. Sometimes in Switzerland, it's already done in Asian cities. They have this vertical takeoff and landing vehicles. For us, it's not so important with which vehicle we have to handle. It could be something like this or what else. We have to take this situation we come and have to handle this. The bigger problem, the crash is one thing, and the other thing is the battery fire. And the battery fires are more challenging for us. That's what we can say, because there are no crash tests for battery fires. Yeah, that's a problem. Not only a problem for us, because when a car is burning, not always the battery is burning. That's for us important to check. Is the battery also involved, or is it only the car, all the things around the battery? And when the battery is involved, then it's much difficult to handle than when it's not. We don't have the batteries only on the cars, we have it in the buildings. I can skip this, but we have more to do with batteries like this. Always in the spring, when all these batteries come back from the storage to the streets, they charge it and they have some failures. We have to do a lot of things with these batteries, not in the main with the big batteries. That's for us to say. And when we have something to do with these BEVs, for us it's really important. We need informations. Where, like this, informations like this. We have software to use. We need to know where is the battery, where are the cables, how can we handle, where are the solutions to disconnect, to bring down the high voltage system to lower the car and. And not only in the cars, this is from this airplane I told you, they also do some rescue sheets. And when I listen to you, you can give a good help to the fire brigade if you have this information available to these special machines you handle with in the tunnels. And also this, I don't have to talk about too much to you to this thermal runaway, but we have a good, we don't do this anymore with nails, and sometimes it's dangerous. But you can see this white smoke now. Now it's nothing. Nothing has happened. This thermal runaway can start immediately, right on the point, or it could go slow and slow and slow, and then can be bigger and bigger and bigger. And this white smoke here, it's a dangerous smoke, and you have to handle this. And now it's the question for me: in which time, or on the time slot, when did the fire brigade come? Is it when it's still the fire is all over, or is it in the beginning? This is this big difference for us how to handle at the end, because this white smoke is easy flammable. You can go with fire and put it on, or it could burn by itself, like this. At the end, for us, we have to stop this thermal runaway to come in a safe situation. I don't have to explain that to you, and that's not always so easy. When you have these big compartments where the battery is inside, it's not so good just to bring the water on the truck or whatever. You have to bring the water inside. And one solution, I saw that when we had the Formula E in Zurich, they have an adapter like this, where you can bring easily the water into the battery. And when I think about your machines, it's not the problem to do something like, not the problem, I'm not an engineer, but on the street, it's with all these nice cars, it's even another situation. But I think this could be a good solution for us to bring the water fast in the battery. And they have one more to bring the water out, 2.5 bar, I don't know the name in English. They have a ventil and goes out. And at the end, for us, the question is where to go with these batteries when it's and the main thing is done. And we work together with professionals. I know in Germany a lot of firefighters do it by itself. We don't. We need partners like this. They bring special containments to put the cars in and can fill in to flood the battery, because how you say, Michael, you have to take care about the water. You can't just put it in a box and put it somewhere. You have to have this water, and it's not without problems, this water. Yeah, we work together with partners, and for me that's the most important things for you to tell our problems, and I'm sure we can discuss some questions, because it's always the question what you expect from us. You can't just call the fire brigade and say, okay, you have to handle this, you have to do some steps before.
But I'm sure we can also, in the round afterwards, discuss what recommendations you have, be it for the owners, be it for the suppliers. One recommendation we already heard. So I hand over to Christoph Müller from Virturail. Virturail was already here in a very nice tunnel project, which is kind of a pioneering tunnel project, where Suva was also involved setting up or did set up a solution. That was also the reason why we invited you, why we got in this contact, because we wanted to share real experience how situation or how solutions nowadays are. And you go very strongly to automation, so I'm looking forward to your presentation.
Yeah. Thank you, Michael. And also, I have to say I'm here with my colleague, Michael Geiger, who is our head of projects and contracts. So feel free to discuss afterwards. And thank you very much also for the invitation. I would like to bring to you a little bit, let's say, from the practice. Virturail is a company dealing with supply systems for mainly mechanized tunneling. I will talk about that a little bit, also about the purpose of our so-called automated service vehicles, then the potential hazards related to the battery electric vehicles, and how do we protect the batteries, and what we did, also together with Suva, with Mr. Araman, to prevent from potential hazards. Virturail is a comparatively new company. It was founded at the end of 2020 or 21, beginning of 21. It's now located in Bludenz in Austria and is a joint venture of my company Mindtronics in Germany and Jägerbau in Switzerland. Mindtronics has a lot of experience in autonomy and also in using of battery systems and functional safety. I was personally working, by example, as a consultant with my companies for Atlas Copco for over 20 years. Jägerbau is known also in Switzerland as a construction company with a very innovative area of tunneling also. So together we created these so-called automated service vehicles, ASVs. These are more or less trains running on rubber tires. So every car in this train, you see here a four-car train, or no, 1, 2, 3, 4 car train. Sorry, I can't see that too. From the Kerenzer Berg tunnel, where all the axles are electronically controlled, so they are running more or less like on a virtual rail in the same track, both inside into the tunnel to the tunnel boring machine and also getting out. This is quite a mathematic, algorithmic challenge to do that, but we are doing that already since some years, so this works fine. The big challenge here was the battery electric integration, so to say. We already did that in Mobiltronics, Mindtronics earlier, so we had already some experience. The entire vehicles, the entire system concept is designed for full autonomy. So we can operate them in different modes and either locally or remotely. Potential battery hazards. We did a lot of investigation beforehand before we went into the tunnel with these things. And we also were reading a lot of publications, and also the report from the battery investigations here in Hagerbach. The Astra report was a big help for us in designing these things. So it came out then the main problem or the main danger is the mechanical damage of the battery. The next thing is high temperatures, of course, shortcuts on the high voltage side, and then also exogenous fire, which overheats the battery. By example, a fire in a completely different situation. It's a very primitive one. A tire starts burning, and then the battery is close to it and it's connected to it. So we can't do anything then. And all these situations, they ultimately may lead to this well-known thermal runaway. And this subsequently results in a battery fire. The battery systems in our applications, they have to comply to safety specifications in the EN or IC 62619. Sorry, I think I need to turn around to make this better here, because my glasses don't allow me to see this. We have to comply to this EN 62619, which, by the way, is under review right now. So, in this review of the IEC 62619, there also the functional safety of the battery management systems has to be taken into account, what Mr. Achermann talked about in the previous session. So, what is our battery safety pyramid, as we call it? The most important thing for us is to protect the battery mechanically. So to find safe mounting locations for the battery, which have an optimal protection against external impact, external exogenous mechanical damage. The next thing is the battery management system. So in this extent, we are only using battery packs which have the certification either to the international ECE R100, which is the norm for battery electric vehicles for lithium-ion batteries in road applications, in on-road applications. Or the other alternative is the EN 62619, which defines the battery safety in industrial and also mobile industrial applications like AGVs, etc. The next step in this pyramid is our onboard control system, our so-called the vehicle control system, which tells to the battery management system, please give us, let's say, this and this power, or charge the battery with 60 amps, 70 amps, and so on and so on. This control system in all our vehicles is a safety control system, a PLD category 3, so internally redundant safety control system, where all the safety functions which are related to the battery safety, braking of the vehicles, steering of the vehicles, are designed in accordance to fulfill performance level D, actually. And the next step in this pyramid is the thermal management of the battery. So this means liquid cooling systems on board of the vehicle, which are taking care of the battery temperature, both in cold conditions but also in warm conditions, in order to make sure that the battery, as far as possible from the environmental point of view, always runs in its, let's say, comfort zone. Yeah? Of course, this is not always possible when the machine is standing outside on the loading area during a very cold Swiss night in the mountains at -20. Then you first need to start up in a different way. And for this, also on the Kerenzer Berg vehicles, by example, there's an external cooling possibility where you can inject external power or heating possibility to start the cooling system in order to heat up the battery. And then, on top of this, there is a last resource. And this is what we call emergency cooling. This is what our firefighter colleague already talked about and what we already heard earlier today. This is an external connection to a water line in the tunnel, which then gets into the battery compartments to cool down the battery up on certain events, which are explained to the driver in the cabin. Because we have steel plates in the bottom, and steel plates on top, and when the vehicle is loaded, there are even the concrete segments on top. So these are a couple of tons which you do not easily throw off in order to get access to the battery. The next topic is the protection against high temperatures. So first, the battery management system provides a protection by degrading the power. So as soon as the battery temperature raises above a certain threshold, this depends on what kind of battery we are using. These thresholds, they may differ, but let's say at a temperature of, by example, 45 degrees centigrade, the degradation of the allowed power starts to get into effect. So at this point, by example, we cannot draw more power than, I don't know, 30 kilowatt or whatever. And our next step in the escalation pyramid is that our control system, the vehicle control system, even allows operation only below the thresholds of the battery management system. So before the battery management system starts power degradation, our control system degrades power. Yeah? By example, by not allowing a higher speed or whatever. And then we have an active liquid cooling system, which sometimes also includes several circuits. And this is consisting of a regular glycol-water mixture. Protection against shortcuts. External shortcuts, of course, in the high voltage system. I mean, our systems deal with 700 on the 700 volt level. So if you touch it, it's definitely lethal. They need to be protected very, very well. The battery containers are first protected by internal power breakers. So these power breakers, they need to be actuated by the battery management system and in turn by the vehicle control system in order to switch on the high voltage at all. Yeah? For this, there is, there's this single wire shielded cabling, so there is an insulation supervision. As soon as there is an insulation fault in between some lines and the ground, everything is cut and operation is not allowed. What we do not like, but there is no alternative right now, are these crazy plastic connectors from the vehicle industry. Yeah? This is simply cheap, but not mining or tunneling proof, point end. Yeah? Because they have such tiny notches all over. Yeah? By example, I can show it. This one there, these are the locking notches. Yeah? After one time of not really very carefully connected, these notches break. And then you get volatile contacts in the supervision circuit which is in there, which suddenly does not allow high voltage to be provided, and then the creative tunnel electricians come with building bridges and stuff like that. So this is something what we really don't like. Yeah? We rather would like to have a mining-proof metal connector and very rigidly locked. The other point is that the internal power breakers of power switches of the batteries, they have a limited lifetime, a limited number of cycles they can be switched under load. And if now you have such emergency stop conditions, etc., when the battery breakers suddenly have to dump the load, then they wear down very quickly. So this needs to be taken care of in the maintenance, because if such a power switch is hanging on in the on position, then you suddenly get the high voltage system powered while you are thinking it is unpowered. And this is a dangerous situation.
Running out of time.
Yeah, okay, sorry. Okay, so the additional operation protections for our batteries are, we are not charging in the backup of the TBM. So we have to have capacity to go in and out and charge outside in the loading area. We are operating the battery only between 20 and 80% of the state of charge. This is the safe area, and this is also the best lifetime area of the battery. We are charging and discharging below the manufacturer allowed current limits, and we have the emergency cooling system. And the emergency cooling system is the ultima ratio. So, in this condition, when the battery comes to a temperature where the thermal runaway, let's say, cannot be provided or is extremely highly likely to happen, then the driver gets an alarm. He has to stop at closest to the next water outlet in the tunnel, connects the emergency cooling hose, which is on the vehicle, and opens the water and floods the battery compartments as an emergency cooling measure. Yeah, and then evacuation and call the colleagues from the fire brigade.
Thank you very much. Thank you very much. I give over to Philip. I think it sounds familiar to you. We can also switch.
I'll also stand there. If you don't mind.
It sounds probably very familiar for an integrator to consider all these things.
Very interesting.
Heavy vehicles, so.
Exactly, yeah. Thank you very much, Michael. So, if we go further, maybe for an introduction first, I'm Philip Strüby. I'm one of the co-founder. I'm actually not CEO of Motix. We don't even have a CEO. We're still too small, to be honest. We were founded in 2020 with the goal of a modular highway e-mobility solution. So we want to provide something in this field. Right now we have about 10 employees and we have big experience in this topic. So we have just the best talents which we could find in Switzerland. So we have mechanical engineering, software talents, and I think we have quite a big knowledge about all kinds of topics involved in BEV development and production. Right now we have a new workshop in Brunnen. We're also fully equipped with equipment stuff, so we have a large production facility where we can test our prototypes, we can build prototypes. The idea is that we also, starting next year, can start making small series production there as well. As you see, we are in the middle of Europe, Brunnen, which is an ideal position for us to deploy all over the world, all over Europe. Maybe that you understand what is Motix doing exactly. So we have at one, since it's everything is battery related, we do a lot of stuff, but I keep it just for the battery topics. Motix is a system integrator. So what we are doing is we evaluate, we choose different kind of components, be it electric motors, chargers, whatsoever. And one component, of course, one of the most important one is the battery. And what the battery manufacturer has to do is stuff like BMS, cells, chemistry, all those kind of stuff. And what we are focused on is that we bring together all the best components which are suitable for the kind of application our customer needs, and we package them into one of our drive units, as you can see in the rendering there, which we provide to the customer, and they can produce vehicles out of them. So this approach here is that they can use existing vehicles, so be it retrofitting ones or even new machines, and instead of using diesel engines, they can use our drive unit, which is fully electric, and all the components are integrated. So you see here, battery pack here, we have a motor here, this one is hydraulic driven, we have charger, cooling system, it's one piece, one single piece, and it's as plug and play as it gets from our point of view. What are we testing, or what is battery manufacturing testing? So on their side is all the software, the BMS technology, they testing, the cell testing, they choose the best cells for the batteries, that's their part. They do all the thermal testing, fire mitigation inside of the battery, that's their part. What we are doing is we test components, individual components, and of course, as soon as we've built our drive units, we test the whole system. Maybe one thing to add here on this slide, I'm also co-founder of Twice Energy, which is another Swiss company which is specialized in the use of second life energy storage systems. You can imagine after like 10, 20 years, the battery might be changed to a new one. And with the old battery, we built energy storage systems for residential purposes and also small to large factories. And there we also develop BMS systems and have stuff to do with cell testing, which is a whole other thing with Second Life cells. But I think we do know a thing or two about batteries, also in a deeper level, not just as a component integrator. Maybe some active risk management, what we're doing. First thing is the manufacturer. I think it's really, really important that we choose the best manufacturer for the application our customer wants. Like I said before, this has a lot to do with knowing your manufacturer, knowing your supplier, knowing their technology, know how they work, what are their safety standards, how do they their testing, is this a serious company or not, because there are a lot of, let's say, cheap or not so professional batteries out there. And this needs to be avoided, because at the end your system is the weakest point. At the end is the battery then, and this should not be the case. What we're also doing is track new state-of-the-art technology development. So we are not just with the manufacturer in developing, looking at new technologies. We're also working with, for example, with Swiss technology companies or Swiss research companies. There are also some companies or some research facilities where they're specializing in cell testing, for example, and there we're always tracking the newest developments, so what's going on in the industry, and then we can compare with the battery manufacturer where we are. For example, one of we just recently did last week was one researcher showed us that you can, with frequency, you can measure the internal temperature of the cells, so really inside the cell level, which you cannot do otherwise. And there you could also maybe have better understanding when a thermal runaway is occurring, because you have a better measurement inside of the cell. So there's a lot of stuff going on in this field, and we're keeping track of this. Then, of course, the system design itself. I think what we've seen with VirtuaRail is more or less exactly what we're doing as well. So all those safety measurements we are designing inside in our system design as well. Then, of course, make sure all components run as designed and also track their health. For example, one thing is also the relay switch, for example. If you have too much extreme shutdowns, you need to have a service maintenance calculated in. And, of course, what's also important, with all the stakeholders sit together, make the risk and mitigation analysis, not just of the system, but also on the whole vehicle. Then third thing is testing and training. We do heavy testing our system, so we really try to make the best testing on the technical side, but also on the real world environment. So we do a lot of testing in-house in the production house, but also we do a lot of testing in the field. For example, also here at Subspace Energy Hub, we have the test track where we run around our machines, make heavy testing, really have it here in the real world environment where we can have same temperature as in a mine or in a tunnel, and to really compare the system. And with the test, it's also important that if we have the test results in, that you really be strict with the measurements you have, and make also a look at the spec sheet of the actual components and compare where we are with the real world results and what is the manufacturer giving us. Sometimes there are huge differences, and this is what we also keep in mind all the time. And of course, last thing is train people and customers on how to use your system. I think the best system, of course, does not need a lot of training, but still you can make it break if you use it wrong at certain points. If you do not maintenance, if you do certain stuff wrong, it's capable of breaking, and this is important that you do the training as well. Then maybe this is like the status quo now, what we've did so far, or what we're doing now with our system. Maybe just to give you an outlook now that we're 3 years old. We learned a lot in all kind of technical directions, and now we want to showcase you what's coming next. and we will shifting from a system integrator into a vehicle designer, let's say. So we will not just design but also build vehicles. It's called MX Platform. Those are some early renderings, so keep in mind they're not finished yet, but this is more or less how it will look like. And it's a completely new platform. It's modular, it's scalable, and it's completely designed and produced by Motix. Everything is integrated directly into the vehicle, so there's like from scratch, this whole vehicle is developed around batteries, around electric motors, all the components needed to be fit in. And for this one, really looking out for the next generation of batteries, motors, all kind of things. So just the latest technology goes in there. It really should be proof of like robust Swiss technology and fulfill the highest standards. Some applications, what you can do with it, so it's a modular system. You can basically build up on it whatever you want. It's up to the customer. We are in the mining and tunneling construction industry, so the first thing probably will be some sort of concrete spraying arm on top of this will be the first application, but also personal transportation, whatever the customer needs is possible. And as you see, it has no cabin, so it will be fully autonomous. And could also be remote driven. I think this is also important. Then maybe some words about the battery safety. As we heard before, one of the most important things is physical impact, or one of the most important things is the mounting point of the battery because of the physical impact. So we have seen quite a lot in those 3 years when they were there driving around in the mine. So stuff like hitting the battery, this will not happen with this thing here. The battery is deeply integrated into the chassis, but still it has all the safety disconnects on the side. It should be easy to reach by firefighters. And also we are tracking now those kind of technologies where you can like put in this water connector. And right now we did not define what kind of measurements we will take. We also try to push innovation, so we will see what's there and maybe we can enhance certain things and make it just the best platform that's available. Yeah, and one last thing, it's the cloud connection. I think it's also important that you always gather real-time data, not just from your battery pack, but from all components, so that you can keep track of what the battery had occurred and what the health at the end really is. So you can have like a lot of impact which happened could be foreseen if you had the data prior. And that's what we're also working on.
Thank you, Philip.
Thank you.
100% control, zero risks. I think, well, curious to find out how far we are, but we are running out of time, so I hand over to you.
So let me just show you a few things. So we make battery packs, okay? And we make various size, shapes, form factors, and every single 138 boxes is now online. So every data sheet for those 138 is available using NMC cells. We also use LFP, and also we use NCA for high power vertical takeoff and landing requirements, which is interesting when we look at safety, whereas aerospace is also extremely specific around safety, but they also need very, very lightweight and high power. So we've got different issues that we deal with. We're also focused on non-road, but interestingly, we get a lot of adjacent markets come to us. And I think one of the biggest challenges we've got as a manufacturer right now is understanding which certification do you guys want. You know, in rail, I can do IEC 63173. I'll turn around and someone wants a military 810H standard. I'll come back, I want ECR R100 on highway. And every single one of those comes with a different suite of tests that are all very similar but not quite the same. So we need to understand what that landscape looks like. So we're a vertically integrated manufacturer, so the only thing we don't make are cells and the chips in the BMS. Everything else is in-house, so we do all of our own BMS software, all of our own hardware, everything is manufactured in Zerotech. Funnily enough, it's in Galway in Ireland, which isn't the most natural place for a battery manufacturer, but it seems to be working well for us. So, let me just try and explain a little bit more about what we're talking about today, which is the fire safety aspects and how we're dealing with it a little bit. And fundamentally in our design, what we've done, it's very interesting we talk about the thermal propagation, So we have a cooling duct that runs through the batteries next to the cells. We have a proprietary foam that acts as a thermal propagation mitigation device. We run the tests in-house, so I'll show you a nail penetration test in a moment, but we also run pack level tests, and we run UL 2580, another standard, hot wire tests for certain clients that want us to demonstrate that we do not achieve thermal propagation even with an NMC fully charged cell in a module, in a pack, and on and on. And we are now in the process of trying to build ourselves a credibility around how we demonstrate those tests repeatedly for each manufacturer, because everybody wants the same data, and I think we're really zooming in on that now. So what you get with one of our modules here is, of course, you've got the opportunity to take the cell data, which you'll see here. You then look at putting some cooling into it without any foam, and then at the other far side you've got a module that we've designed that has a foam. So the left-hand side is what you see with no propagation. The middle is what happens when you just put some cooling system in there, which is active. And on the right-hand side you get complete containment by having both foam and a cooling system engaged. Now that's exactly the same cell going off within a module. So I think what I'm trying to get across here is the cell chemistry is important, but how you use that cell chemistry in the design of your battery module is more important, because every single cell, including LFP, can cause a fire. I've got other videos showing packs and things if you want to have a look at those later, but we can demonstrate that that's a 21700 Samsung 5 amp hour charge at 4.2 volts. And that goes into our way that we design our battery packs. So very short and sweet. If you want any more information, just come and give me a shout and we'll take that up for you. Hope that sped it up a little bit for you.
I hand over to Christoph from Normet. Normet is changing the full fleet of their machines for mining and tunneling to 100% electric, so I think you are facing still a lot of challenges, not everything solved. We are looking forward to your presentation, Christoph.
So make it short and sweet, yeah. I said for Normet, it is very important, being part of, let's say, actually driving that change into the battery electric vehicles on the ground. I skipped that. I'm in the industry for 20 years plus, let's say, with an engineering background, etc. But yeah, let's keep that. At Normet, the idea is, or the concept is that we use a standardized concept where we have all the different applications or machines around it, but we apply the same safety measures in that, let's say, the drive system, which obviously is the battery itself, all these components which have been mentioned before, and then the drive itself on the axle. So we apply the same on all these machines. As you can see, these are mainly, or at least what are pictured here, this is for mining, but there's also, let's say, tunneling versions out of that. When it comes to, let's say, the risks, what we have today at Normet has been in the mining industry for quite a long time, I would say. So the risk what we have today, and since most of the machines still run on diesel, is actually the heat that is generated. And where is that generated? That's mainly exhaust manifolds, turbochargers, then retarders, where you easily reach temperatures 300 degrees Celsius or more. And then together with the fuel you have on board, or can be 300 liters of diesel, there's a certain risk. So these 300 degrees is kind of critical, since this is the ignition point of let's say, oils and diesels. So today there is, let's say, not only our equipment, but throughout the industry, there are fires, I wouldn't say every day, but it's common on the ground. And unfortunately on the ground, that's a big risk. So the idea here is, or the concept is that we use these battery systems, which obviously then reduce the heat generation at all. So we hardly reach actually ignition points. I mean, we still have hydraulics on these machines, obviously to move booms or concrete pumps, but you never get to these temperatures, which actually will then ignite any oils what we have there. So and also with that, we can also reduce the amount of oils we have on these kind of machines. So there are different, let's say, measures we take. As a first line of defense, we utilize the safest line, lithium-ion chemistry, LTO. So shouldn't be a problem in Switzerland, I guess, with LTOs. As a safe, one of the safest chemistry on the market today, for sure. The company is also looking at other chemistries, but let's say maybe coming from the mining industry, where safety is absolute a must, and that was especially in the beginning the safest thing available on the market. So again, here utilize a proven supplier of the battery packs. And then, let's say, these passive safety measures, I think you don't have to repeat that. That's what colleagues already mentioned today a couple of times. So this is the first line of defense. Second line of defense is we have these active safety measures, over under voltage protection, temperature control, short circuit protection, rollover sensor when a machine is actually rolling over, tipping over, the battery is disconnected, everything is put into a safe condition. Then third line of defense, we all know there is hardly any system that can extinguish a battery on fire. There is a fire extinguishing system installed on every machine, but for sure that's for the rest of the machine and not for the battery, obviously. And then maybe also to your comments earlier today, it's not only, let's say, when you have to service a battery, etc., it's also very important that you can take that battery out, put it in a safe container, and transport that to safely throughout the mine or the tunnel to the place where you then service that battery. So this is also part of, let's say, the whole concept here to mitigate the risks. There is, let's say, a recent and quite nice development here. What I wanted to show you is there is a remote monitoring system now, let's say the first or one of the biggest one now in place in India, where with a big customer, mining customer, actually as a company we monitor their equipment running underground. So as you can see, one of the colleagues, he and his colleagues, they're sitting there and monitoring it actively. For sure there are thresholds built in, let's say, temperatures on, for example, these retarders, etc., from the diesel machines, where then will trigger an event, or then actually they really following up what's going on with a fleet of 20, 30, 40 machines in operation on the ground, and then kind of call whatever these guys involved with these machines and say, well, I see there is a rise or let's say, I see that the brakes, for example, there's a rise, the temperature is going up, please check, is everything in order, or it's really to help the customer. The customer really appreciates that we somehow help with their daily operations. I also mentioned before, what we do is we try to run the battery in their comfort zone, as you call it. So really say, okay, temperature is really without, let's say, the best range, and as you can see, this is an example of 3 machines now, and they're running very comfortably between 18 and 30, 35 degrees, which is for a battery, comfy, I would say. And we try to limit that into that zone, which means like that adds extra, let's say, a safety layer on it. The same also here, the state of charges. So we don't go from 0 to 100%. We limit that for sure. We limit a little bit of the capacity, but again here that helps very much to keep the battery in very good conditions. Another part is, as an international company, we have currently about 70 trained and certified professionals. For sure that was kind of a ramp up now, since this technology is still new, or kind of new, So we have trained these people, we have certified these people on different levels, and they're distributed around the globe. So where, let's say, our customers are, or then we fly them in and out to help also the customer to let's say, to get their people trained on site. So either we're normally as companies, there are, for example, service contracts where we have our guys there permanently, or then by temporary that we bring in these people and train the local staff. That helps very much. And now I think this is answering one of your questions. Also, the safety leaflets, very important. I think for all the firefighters to know, you know, where are the elements to switch it off? Where actually are the batteries? How are they connected? Where are these, let's say, heat sources, etc., etc. I think this is very important. And for us, probably one of the first things that is trained, or when a machine is commissioned, that is actually then shown to people, firefighters, fire brigades, there, you know, how to, you know, to act or react when something is happening. So as a company, we have been very much involved in this safety assessment together with customers. It is still new with customers. It's for sure some parts are also new to the company itself. So there is a very lively exchange and risk assessment we do together. We see ourselves as being in a key role in this, since this is kind of also new, and we really want and we drive it actually forward. And for us, also important that this education or training with the local staff, but also that we share this information with others in the industry. I mean, we are on the same boat in the end, so it's very important for us that we share, that we learn from each other, and get, let's say, with the goal that this technology is accepted as fast as possible. Maybe the mine is a bit ahead, the tunneling, but I'm pretty sure tunneling will follow pretty soon.